Okay, so kind of as alongside all of the changes that are occurring with the age of absolutism is this focus of changes in science. So the scientific revolution is this kind of sporadic, gradual movement, I guess you could say, of people focusing on a new way of thinking about the natural world, using observation, but then kind of expanding on that with the use of experimentation and questioning. So it starts in the mid 1500s, but it continues through the 18th century. So that's kind of why I say it's sporadic or gradual, and that it's not just at one point in time people say, oh, let's suddenly make all of these changes. These changes kind of develop over a series of time. So various causes, the Renaissance and kind of rethinking about how the Greeks and the Romans had understood the world, looking back at the information they had presented, but also the Renaissance had been spurred by that connection with the Muslim world or the Arabic world. And so that is going to help lead into these new advancements as well. The age of exploration is going to have a huge impact because as the Europeans had kind of been confronted with, there's new animals, there's different types of people in the world that we didn't realize existed. Now, how do we kind of grapple with that information and finding these new truths about the different species that they've been introduced to in this different kind of world that they had previously thought was didn't exist? The invention of the printing press is going to allow for increased literacy, but then also this increased publication of materials that challenges the older beliefs and new observations, not just kind of thinking it or looking at something and expecting that it is truth, but testing it. So previous science had come from Greco-Roman developments, and we're going to specifically kind of cite some Greek scientists. So as they understood the world, they looked at it through that lens of these were Greek advancements, these were Roman ideas, and kind of bridged that as well with this idea of Christianity. And so Christianity believed that the earth was at the center of the universe. So one of the big theories that you want to know is the geocentric theory here. And that's the idea, again, that the earth is at the center of the universe, and then everything else kind of orbits around the earth, right? Well, we obviously know today that that is false, but you have to understand that at this time, just thinking about where you're standing. So if you're sitting in the class right now, you don't feel like you're moving. If you were to observe, you could see that the sun sets in a different location than it rises from. And so just from observation really alone and your use of your senses, it would appear that potentially the earth is the steady and not moving. And so Christianity expands on this and says that yes, God created the earth, and the earth was meant to be kind of the center of the universe, and everything else kind of revolved around that. So they bring about this idea of that geocentric theory, and most scientists don't really question it. Now, you do have, again, the Arabic world that had been making advancements in science and kind of challenging those assumptions, but not the Western Europeans, really. And so one of the first scientists, as far as the Western world is concerned, that is going to challenge the geocentric theory was Nicolaus Copernicus. So he was a Polish astronomer, and he is going to, for about 25 years, do various studies to kind of understand astronomy. Now, Copernicus knows that whatever he presents is going to challenge tradition, and it's inevitably going to challenge the church. Again, the church believes the earth is at the center of the universe. So he's very careful about what he does. And so he, publishes his findings, but he waits until it's the last year of his life. So he waits until 1543 and comes up with this idea of the heliocentric theory, and that the sun is at the center of the universe. So, it's going to challenge this idea or this concept that the earth was the center. One of the things, hopefully you'll notice in that image as well, is that they're purely circular orbits, right? And so you're going to see that there are other scientists that kind of come around. And so Tycho Brahe is going to be one, and he is going to, I argue that, or come up with the mathematics behind this idea that maybe it's not solid elliptical orbits. Now he's going to pass away, and so his student, Kepler, is actually going to be the one that publishes the findings of the elliptical orbits. He just uses the math and the observations that Brahe had done, and so he's kind of the one that actually gets credit. But now we realize that there are such things as elliptical orbits, and so that's what we understand today. So this is where a lot of our current astronomy is going to come from. Then you have Galileo Galilei. So probably one of the more significant or more known scientists. And Galileo is really kind of going to reflect the conflict that the scientific revolution brings about. So the telescope had already been invented. He did not invent the telescope, but he did expand upon it to create one to where he could see further. And so he builds this enhanced telescope in 1609, and Galileo kind of documents what he sees. So the sun has these dark spots. Our moon is not made from this perfect matter that Aristotle, the former Greek, had argued that the Earth and the moon were perfect substances. So he challenges that. He recognizes that Jupiter had 4 moons, and in that really kind of reveals that he does support Copernicus and Copernicus's theory. So his initial findings that get published, the church silences him and basically says, you need to stop. Galileo does and doesn't. He continues on with his research, but he's not going to publish anything for 16 more years. So while he's still furthering the research, documenting information, it doesn't actually get published for another 16 years. However, once he publishes that work and again kind of says, no, Copernicus is correct, the Catholic Church is going to demand that he go on trial with the Inquisition. And most of the punishments for the Inquisition were exceptionally harsh and could even result in execution because you're charging with heresy and saying that the church is wrong. And so Galileo is forced to read this letter that is already typed up, and it's this admission where he says that Copernicus was false, that he is basically recanting the information he already presented. Now, he knows that this is wrong, but he also knows that it's kind of his life is on the line here. And so he does recant, and then he's put on house arrest until his death. So it shows that, yes, there are these advancements being made, but there are severe costs that come with them because you are directly challenging the church if you're arguing that, there's not this perfect matter, but that also that, what we had been saying for years and what the church had been saying for years wasn't true. So there's some other advancements, one of which you probably are very familiar with or should be very familiar with, and that's the use of the scientific method. So again, instead of kind of just using observation, you're going to follow this process of experimenting. So you'll have a question, you're going to experiment, and then you can draw your conclusions. And again, all of these are theories. They're not something that is 100% capable of being proven, right? But the experiments show, okay, here's my results. I can argue or claim that the theory is that this is what happens. So Francis Bacon is going to kind of be this father of the scientific method or empirical research, and argues again that you can have a question and then you begin your experiment on it, and then you can draw your conclusions before just kind of using observation. So you actually need to go through that process and don't just accept the assumptions. Rene Descartes expands upon that. He is more of a mathematician than a scientist. But he is going to bring those two fields together. And again, I focus on this idea that you can't just have these assumptions and expect that, well, because we believed this way, it's real or it's true. He's going to say that you need to use math and science and to understand the world. Isaac Newton is one of the prominent scientists as well, which you will have learned about or will continue to learn. And so he adds on to those previous developments, but focuses on the laws of gravitation and motion. So on the right side, you can see what those laws were. So the objects at rest remain at rest, objects in motion remain in motion, force equals mass times acceleration. I used to love having to do those little questions in science. For every action, there's an equal and opposite reaction. So those are your Newton's laws. And so he is one of the pivotal figures in the scientific revolution as well, but he's going to come much later than you would have seen like Galileo or Copernicus. So he also identifies as Christian, and so argues that the universe is like a clock and that God is its clock maker. He is what put everything into motion and kind of dictates that, but yet you can still use science to support Christianity. Other developments that are kind of interesting, you have the first microscope that is developed, a barometer, so what you kind of use to understand your weather. One of the first thermometers using mercury. Advancements in anatomy. So the Greek scientist Galen, which is where you have like the Galen School of Nursing, Galen College, was a Greek scientist, but he never actually studied the human body. He like studied or dissected like pigs or other animals. And so what you actually see now is that as we move in further into history with the scientific revolution, they're actually going to dissect humans and kind of look at the body. And so this published work of your bones and your muscles and your organs comes out. Now, again, the Arabic world had already been doing that, but you're going to see Western Europe kind of makes advancements. And then you also have inoculation where you're going to inject a strain, for a vaccine. So one of the examples is going to be with the development of the smallpox vaccines. They kind of use the strain of cowpox to understand and then develop this vaccine to help prevent the spread of smallpox. All right, so that's the scientific revolution.